Okay, so example on how to solve this system of equations. Okay, the first thing I identify here is that we have two incognates, x and y. But x and y are inside this whole operation, right? Which is kind of annoying. So one thing I like to do, it is not like mandatory, but I like to do it so it doesn't like stress me. What I'm going to do is a little substitution. I'm going to call tan x minus 3 z. Why not? I'm choosing this arbitrarily. And sine of y plus 2, I'm going to call it t. Now I'm going to rewrite the system. So I'm going to have 2z plus 4t equals 1. And then 4z t plus 1 equals 2. Now this looks a little bit less intimidating, and I'm going to try to do it with patience. So first, I'm gonna solve the system with reduction. So I want them in the same format. Like on this row, I want the z, here I want the t, and here I want a number. I'm choosing this arbitrarily again. The first thing I'm gonna do is I'm gonna move this onto the other side, multiplying. So I'm going to be working on re-expressing this equation. All right, so let me get rid of this. We don't need it anymore. And I'm going to leave this just in case I forget what my substitutions were. So let me develop this. That would be 4z equals 2 times t plus 1. Now I'm going to develop the bracket. 4z equals 2t plus 2. And now I'm going to express it on the other format. 4z minus 2t equals 2. So this is congruent to this. Yep. Is there any question on how I did this? Okay, this means that if this is equal to this, I can re-express the system. And I'm going to re-express it again here in blue. 2z plus 4t equals 1. And my other equation is 4z minus 2t equal 2. Okay, now I'm going to solve this. I'm going to get rid of this. Okay, so let's solve this system. I'm going to solve it by reduction. Okay, so first I have to choose a variable that I want to destroy. And I'm going to choose the t's. So in order to do that, I need to multiply this whole equation by 4. Okay, let's do that. If I multiply, sorry, by 4, what am I saying? By 2. By 2. If I do that, I'll get 8z minus 4t equals 4, which is great, because now I can add them. And when I add them, the t's will vanish. So I'll get 10z, nothing, well, nothing, 0. 1 plus 4, 5. So z is equal to 5 divided by 10. So z is equal to a half, or 0.5 if you prefer. Now, I need to remember that z comes from this. So I need to find x really, which is what I was looking for. Now I know that tan of x minus 3 equals z, and z is 0.5. So I need to find x. If tan of x minus 3 equals 0.5, x minus 3 equals arctan of 0.5, which is, I don't know how much that is. And arctan of 0.5 plus 3 should be x. Now, if you want to find which value more or less arctan 0.5 has, you can look it in your calculator. Great, we found x. Now to find y, we need to find t first. How do I find t? Well, I know that z is 0.5. So to find t, I need to plug in z in one of these two equations. I'm going to choose the first one because it looks more simple. So 2 times 0.5 plus 4t should equal 1. 2 times 0.5 is 1. If I bring the 1 to the other side, it will be minus 1. Well, let me do all the steps. 1 plus 4t equals 1. 4t, 1 minus 1. So 4t equals 0, therefore t equals 0. Now that I've got t, I need to check in here what y is. So sine of y plus 2 should equal 0. Therefore, y plus 2 should equal arc sine of 0. Arc sine of 0 is 0. So y plus 2 equals 0. Therefore, y should equal minus 2. And we have found a solution, although there is infinite solutions to the system, but we have found one that works.